We discussed the different properties of transition elements. Now we have to see the relationship between E0 value and the reactivity. What is the relationship between E0 value and the reactivity? Only here, I'm discussing only a few examples. If we examine the E0 values for the redox couple M3 plus bar M2 plus, M3 plus bar M2 plus. For example, Fe3 plus bar Fe2 plus, Mn3 plus bar Mn2 plus. If we examine these E0 values, we can identify Mn3 plus and CO3 plus ions are the strongest oxidizing agents in aqueous solution. What will be the reason? No, in Mn3 plus D4 configuration is present. D4 configuration, Mn3 plus. It has always the tendency to change it to D5 configuration. So always it will try to accept one more electron, therefore it can act as oxidizing agent. So Mn3 plus is a strong oxidizing agent. And in the case of CO3 plus, now the configuration is cobalt 3d7 forest 2 configuration. And therefore, these two Mn3 plus and CO3 plus are strongest oxidizing agents in aqueous solution. You will understand it when you analyze the E0 values. In the case of manganese, it is very easy to understand because the stability of D5 configuration also can be used to explain it. But in the case of CO3 plus, we cannot see such a configurational stability. Here we can explain it only on the basis of E0 value. E0 value is depending on various things. In the same way, the ions Ti2 plus and V2 plus and Cr2 plus are strong reducing agents and will liberate hydrogen from dilute acids. Ti2 plus, V2 plus, Cr2 plus, they are strong reducing agents. We can explain it very easily with the E0 values. Reducing agent means they are ready to give one more electron. So Cr2 plus is ready to give one more electron. Why? Already we explained it. In Cr2 plus configuration is 3d4. If it remove one electron, it will get 3d3 configuration, that is a stable configuration. So based on the electronic configuration, we can explain it. But in all the cases, it is not possible. Which are the questions that is possible from this part? See the question. Why is the highest oxidized state of a metal exhibited in its oxide or fluoride only? What is the reason? We know fluorine is very small in size, oxygen also very small in size, and when we compare the electronegativity values, they are the highest electronegative elements. And that is the reason. Oxygen and fluorine have small size and high electronegativity. See the next question, which is a stronger reducing agent, Cr2 plus or Fe2 plus, and why? What is your answer? Already we mentioned Cr2 plus is a strong reducing agent. That is the answer. Cr2 plus is the stronger reducing agent. And what is the reason? Compare the E0 values of E0 of Cr3 plus bar Cr2 plus and E0 of Fe3 plus bar Fe2 plus. You can see E0 of Cr3 plus bar Cr2 plus is negative wise. 0.41. But that of iron, Fe3 plus bar Fe2 plus is positive, plus 0.77. So Cr2 plus is stronger reducing agent. Now here we have to discuss the compounds of transition elements. Their oxides and oxoanions are very important. Oxides can stabilize higher oxidation states, already we mentioned. So the compounds of transition metals in which the transition metals are in higher oxidation state. What are the peculiarities of these compounds? We are analyzing only 2 points here. All of you know, in the case of manganese, Mn2O7, in which manganese is in its highest oxidation state, Mn plus 7. Mn2O7 is a covalent green oil, means liquid. So it has low melting point. That is one of the characteristics. Low melting point. What is the case of CrO3 and V2O5? In V2O5, vanadium plus 5 oxidation state, and in CrO3, chromium is in plus 6 oxidation state. In these two cases, the melting point is low. And what is the second property? Acid character is predominant. If it is in the highest oxidation state, can only accept electron, cannot give electron, it can only accept electron. The species which can accept a pair of electron is known as acid. So higher oxidation state has acidic character, or acidic character is predominant. In detail, we will discuss only 2 compounds. One is potassium dichromate and the other one is potassium permanganate. If you check the previous year question papers, you can see all the question papers you will get question from potassium dichromate or from potassium permanganate. So one of the very important topic of this chapter, preparation and properties of potassium dichromate and its structure. What is the formula of potassium dichromate? K2Cr2O7. And this dichromate, potassium dichromate, it is generally prepared from chromate ore. Chromate ore has the molecular formula FeCr2O4. Chromate ore has the molecular formula FeCr2O4. So potassium dichromate is prepared from chromate ore. The chromate ore, what is the first step? It has 3 steps. And in the first step, chromate ore is treated with the sodium or potassium carbonate in presence of excess of air. Chromate ore, FeCr2O4, is treated with the sodium or potassium carbonate in excess air. Then you will get sodium chromate, Na2CrO4, along with Fe2O3 and carbon dioxide. So FeCr2O4 chromate ore, when treated with the sodium carbonate in presence of oxygen, we will get sodium chromate. The yellow solution of sodium chromate is filtered and acidified with the sulfuric acid. A simple process. Simply add acid to sodium chromate. Then sodium chromate will change it to sodium dichromate. That is the second step. Conversion of sodium chromate to sodium dichromate by the addition of dilute sulfuric acid. The equation is given here. Na2CrO4 plus 2H plus gives Na2Cr2O7 plus Na plus H2. And in the final step, third step, sodium dichromate is converted to potassium dichromate by the addition of potassium chloride. Sodium dichromate is more soluble than potassium dichromate. Therefore, potassium dichromate is prepared by treating the solution of sodium dichromate with the potassium chloride. You can see the equation here. Na2Cr2O7 plus 2KCl gives K2Cr2O7 plus 2NaCl. Now we can see the structure of dichromate ion and chromate ion. Chromate ion, you can see a tetrahedral structure. It has a tetrahedral structure. Here, two tetrahedral structures are combined together in dichromate ion. You have to study to draw the structure of chromate ion and dichromate ion. The chromate ion is tetrahedral. Dichromate ion consists of two tetrahedra sharing one corner. And this angle, CrO-Cr bond angle, is 126 degrees. Okay, I think it is enough for today. And today itself, you have to study and write this portion.